Going on now to section 7 of chapter 1, in which we're going to be dealing with multiplying and dividing real numbers. There are two basic rules when you are dividing and multiplying, and I have them over here as a little summary. If the factors you are multiplying have the same sign, that is, they're both plus, or that they're both negative, the product of that, that is, when you multiply factors with like signs, both positive or both negative, the results are positive. If they are unlike signs, that is, one is positive and one is negative, then the results are negative. So a procedure, a strategy for doing this would be look at what you have and then determine the sign of the answer. Then don't worry about the sign anymore because you've determined what it will be. For instance, in example 1, we have one negative and one positive. So the answer is going to be negative. Here we have one positive and one negative. They're unlike signs, so the answer is going to be negative. Here they are both the same signs, two negatives, and we had a little bit of this in the previous chapter, so that answer is going to be positive. Remember, if it's a single term and it's positive, you don't put the sign there. So this is going to be a negative 32. This will be a negative 14. And this will be a positive 90. And as you do your practice, you'll see you have many examples of this. All right, in example 2, now we have 3 factors. Now an interesting thing here is whenever you have a string of factors, and there's a 0 in that string of factors, the answer is always going to be 0. Because 7 times 0 is 0, and 0 times negative 6 is 0. So if there is a 0 in a string of factors, you don't have to worry about the sign, the answer is going to be 0. Now here's a case where we have 3 negative signs. And the key to this is if you have an odd number of negative signs, that is an odd number, then the answer is going to be negative. If you had 4 negative signs, that would be an even number, then the answer would be positive. So that's a little trick if you can remember it. Odd number of negative signs, the answer is going to be negative. Even number of negative signs, the answer will be positive. So what we can do here is this is going to be a 6. 6 times 4 is 24. Now here we have an even number of negative signs. There's just 2. So this answer is going to be positive. And it's just 5 times 9 is 45. Again, we don't write the positive. I'm just emphasizing it here. Now here's an interesting thing. Again, these are you're going to multiply. This gives us a positive 44. Now, this gives us a negative 10. A positive 5 times a negative 2. But then it's the opposite of a negative 10. Now another way to look at this is you can make this one a positive, make this one a negative. Now you see that that's going to be a positive 10. So this ends up being 54. Again, you're going to have to work on your techniques. Remember the rules. Through practice, you'll gain mastery. As we go on to something like this, again, that strategy of figuring out what will your end answer sign be. That is the sign of your product. Good technique. So here it's a negative times a positive, so this answer is going to be negative. Positive times a negative, so this answer will be negative. Negative times a negative, so this answer will be a positive. And now we'll work on the next thing. Now again, if you're using your calculator, just putting that in, you're going to get the right number of decimals. But basically, you're going to need 3 decimals in your answer. So if this were 12 times 5, I know that's going to be a 60. But where does the decimal go? Well, we'll have to probably work it out here. So we have 0.05 and then 1.2. We know the answer is going to be negative. So this is going to be a 0. This is going to be a 10 there and a 0. This is going to be a 5. And that's basically it. So I get 0, 6, 0. I could put down, how many places do I need? There's 1, 2, 3 decimals. So my answer then will be like so. We usually like to put a 0 to lock in where we're putting the decimal place. And that's this answer. And again, if you use your calculator, it's much easier. Now again, we have a negative and a positive. Our answer is going to be negative. Can we cross cancel anywhere? Yes. Take a 2 out of there. 2 out of there gives me a 5. So I end up with a negative 7/15. Now remember, if I do the canceling in here before I multiply, once I get a product, you can't simplify it anymore. And again, this is 20 over 1. 5 will go into there once. 5 will go into there 4 times. And we know it's going to be a positive. 4 times 4 is 16. Now, as we go on to example 4, we're looking at exponents. And notice that this and this look like they're the same, and this look like they're the same, but there is a basic difference. Here, our base is a negative 2. Here, our base is a positive 2. The negative sign is not included in the base that we are cubing. And the same thing applies there. So let's see what happens. Here we have a negative 2 times a negative 2 times a negative 2. That is an odd number of negatives. So our answer is going to be negative. And then 2 to the third we said was 8. Now here we're cubing the 2. That gives us an 8. Then we are going to apply the negative sign. So actually both of these, actually it's coincidental that they come out the same. Because watch what's going to happen here. Here, this is going to be a negative 3 times a negative 3. That is an even number of negatives. This will make it 3 squared is a positive 9. But keep in mind now, the base is a positive 3. 3 squared is a positive 9. Then we apply the negative. So we're going to square the 3 first, then apply the negative. Here, we're squaring a negative 3. So negative 3 times negative 3 gave you your positive 9. Here we squared a positive 3, got a 9, then applied the negative sign. So here it shows you that it doesn't always come out the same. And you have to be careful of that. That's a critical point, and often where students will make an error. As we go into this next topic, we're going to have a new vocabulary word, reciprocals. And by definition, what is a reciprocal? Well, when you have a number A, and that number is A over 1, every number is over 1, we just don't write it. The reciprocal of that would be take that number and then flip it, so the 1 now goes to the numerator place, the A goes to the denominator place, and the product of multiplying a number by its reciprocal is a positive 1. So what is a reciprocal? A reciprocal is a number that when you multiply it by its reciprocal, the product is a positive 1. So with that in mind, let's see what we have here. Now again, this is 22 over 1. So the reciprocal would be 1 over 22. Because if we multiplied that, the product would be 1. And the reciprocal of a fraction, again, it's just flipping it, 16 over 3, because everything would cancel out, and that's a 1. Now, it's important that if it's a negative that you're starting off with, its reciprocal, and I ran out of room there, let me write it up here, is a negative 1 over 10. So you have to use the same sign so that when you multiply negative times negative, you get a positive 1. And the same thing here, you're going to multiply this by a negative 13/9. So everything cancels out, and negative times negative gives you a positive. So once again, I'll just highlight it in red. The reciprocals are so that when you multiply a number by its reciprocal, the product is 1. Now as we go on to dividing real numbers, a nice thing is the rules are the same. So if we have two terms that have the same sign, it will be positive. If they have different signs, the results will be negative. So again, a strategy would be determine the sign of your answer. Here we have a negative divided by a positive. So this will be a negative. A negative divided by a negative. This will be a positive. A positive divided by a negative. This is going to be a negative. Then you can actually do your division. Remember, you could set it up like this too. So 3 goes into 18 6 times. 2 goes into 14 7 times. And 4 goes into 20 5 times. And again, the strategy, like signs, answer will be positive. Unlike signs, answer is going to be negative. And we'll show you a technique here, but the answer to this one will be negative. And again, negative divided by a positive, the answer will be negative. Okay, so we've determined the signs. Now we do the division. This is going to be a 6. This is going to be a negative 12. Now, you may recall this from earlier classes, that when we are dividing a fraction by a fraction, what we do is we convert that to a multiplication problem. This first term stays the same. We take the multiplication, the division, change it to multiplication. Now take the reciprocal of that, and that would become 4/5. Now remember, we determined the answer is going to be negative. Otherwise, you'd have to stick that, negative in there so you don't forget. But we've determined it's going to be a negative. And then if you can cross-cancel anywhere, you would. And I don't see anything cross-canceling here, so this is going to be 8/15. And again, we're going to change this from a negative 3/2 times, we're going to change that from a division to multiplication, take the reciprocal, but here something cancels out. 1, 3, so this is going to be a negative 1/6. Check your work on your practice, because that will develop mastery. Okay, on page 56, they're going to introduce some concepts involving 0. Now, whenever we have a real number other than 0 divided by 0, this is something that in mathematics we don't define. So we say that is undefined. It's not 0, it's undefined. So any real number other than 0 divided by 0. Now, again, any number, real number on top, any real number divided by a number other than 0, this equals 0. And notice that when we have 0 as a factor, this top becomes 0. Divided by 2, it's the same as this one. That is also 0. So again, this is crucial. You may want to put like a little star or something. Anytime you have a real number other than 0 on top, divided by a 0, it's undefined. And then, as long as it's not a 0 in the denominator, but 0 in the numerator, the product is 0. Okay, in example 9 now, they're giving you kind of a complex problem a little bit. You got to do it in pieces. Here we have two negative signs. So this is going to become a positive 36 plus 3 gives me a 39 on top. And then this is the opposite of a negative, makes that a positive. So this then becomes a negative 10 on the bottom. Now, generally, when we write a negative in our answers, we don't put it in the denominator. We move that negative sign up to the division bar and put it there. All right, in letter B, we are going to square this. A negative 3 times negative 3 gives you a positive 9. 2 times 9 is 18. Minus 20 on top will give us a negative 2. Adding these together gives us a negative 1. Negative divided by a negative just gives us a positive 2. We don't write the 1. But remember, every whole number has a 1 underneath it. We just don't write it. Okay, in this next one, example 10, they want us to do some substitution where x has the value of negative 2 and y has the value of negative 4. And these are our original examples. And you notice I've used parentheses to substitute. You might say, why? Well, because you don't want to get the signs confused. So let's work the signs a little bit here. In letter A, 5 times -2, this is going to be a -10. Now here we have the opposite of a -4, which makes it a +4. So this ends up being a -6. Now here, again, our x is what is our base, and that's a -2. Raised to the 4th power, an even number of negative signs. And then 2 to the 4th is 16. And then this is going to be, again, the opposite of a negative makes it a positive. 2 times 4 is 8. So this ends up being a positive 24. And again, here we see a negative divided by a negative, so that answer is going to be positive. And actually, this will cancel here a little bit. So on the top, we get 3, and on the bottom, we get 4. So we would have had 6/8, which reduced to 3/4. But if you could do some canceling, but again, master that strategy of working with signs so you know what sign your answer is going to be without waiting till the very end. For this last example of this section, we're talking about a golfer that for 3 days shot 7 under par. And I'm not going to explain the golf game here, but that means it's a good thing to shoot under par. So how much did he shoot under par for all 3 days? Well, we have to remember that under par is a -7. So that 3 times -7 gives us a -21 under par. Okay? Or I may be a little redundant here that I think. Because under par implies the negative here, so maybe it's just 21. Let me see what the book says here again. Yeah, they say it either way. It's, if you say under par, you would say 21 under par, or a -21. Because implying under par implies the negative. Okay, just to clear that up. I'm not a great golfer either, so. All right, well, we're almost finished.